You think light moves fast because it's in a hurry. You imagine it racing through space, choosing the speed limit, obeying some cosmic traffic law. You picture it like a car that could go faster but doesn't. That's wrong. Light doesn't move at light speed because it's fast. Light moves at light speed because it has no choice, because it doesn't experience time, because from light's perspective, if it had one, the entire history of the universe happens in 0 seconds. You think the speed of light is about light. It isn't. It's about you, about mass, about why you can't reach it. Feynman saw this. He didn't just accept the limit. He asked why the limit exists at all. And the answer isn't what you think. It's worse. Because the speed of light isn't the maximum speed. It's the only speed the universe actually has. You've been lied to, not maliciously, but lied to nonetheless. You've been told that the speed of light is the universe's speed limit, that nothing can go faster than light, that 299, 792, 458 meters per second is the cosmic speed limit sign posted by the laws of physics. This makes it sound like light could go faster, but chooses not to, like there's some rule preventing it, like the universe is enforcing a maximum. That's not what's happening. The speed of light isn't a limit in the way you think limits work. It's not like a highway with a posted maximum. It's not a barrier you hit if you push hard enough. Here's what actually happens when you try to go faster. You add energy to an object, you accelerate it, it speeds up. You add more energy, it speeds up more. You keep adding energy more and more, expecting that eventually, if you just add enough, you'll hit light speed. But you don't. The object gets closer, faster and faster. Yes, but never there. It's not because you ran out of energy. You could have infinite energy and it still wouldn't work. The object would get closer and closer to light speed, 99%, 99.9%, 99.99%, but never reach it. This isn't a practical limitation. It's not an engineering problem. It's telling you something darker. The speed of light is not a speed that things reach. It's a speed that massless things are always at. Light doesn't accelerate to light speed. It doesn't start slow and build up. From the moment a photon exists, it's moving at light speed, not because it's fast, but because it can't do anything else. The speed of light is not the maximum speed in the universe. It's the default speed. And the question isn't why light goes so fast. The question is why you go so slow. Let's talk about what happens from light's perspective, except we can't, because light doesn't have a perspective. Not because we lack the instruments to measure it, but because from light's point of view, there is no point of view. There is no experience. There is no journey. A photon leaves the surface of a distant star. It travels for 1 billion years across space. It enters your eye. You see the star. From your perspective, that photon had a long trip, a 1 billion-year commute across the cosmos. From the photon's perspective, and this is where your intuition breaks, 0 time has passed. Not very little time, not almost no time, exactly 0. The photon is emitted and absorbed in the same instant. The start and end of its journey are the same event. There is no duration, no voyage, no 1 billion years of darkness and silence. The photon doesn't experience a journey because at light speed, time stops. Not metaphorically, not poetically, literally. This is what time dilation does at the extreme. As you approach light speed, time slows down for you relative to the outside world. At 90% light speed, time runs slower. At 99%, slower still. At 99.99%, it's crawling. At light speed exactly, time doesn't crawl. It stops entirely. For anything moving at light speed, the universe has 0 duration. The Big Bang and the heat death of the cosmos happen simultaneously. All of space collapses to a single point along the direction of motion. So when you imagine light traveling through space, you're imagining it wrong. Light doesn't travel, it connects. It links one event to another with no subjective gap in between. Emission and absorption are the same moment, separated only by the external geometry of space-time. This is not a feature of light. This is what it means to move at light speed. And here's the disturbing part. This tells you that light speed isn't about motion at all. It's about the structure of reality itself, about how cause and effect propagate, about the minimum distance, temporally and spatially, that separates one event from another. Light doesn't go fast. Light reveals the speed at which the universe updates. You think you're slow because you're heavy. That's backwards. You're heavy because you're slow. Mass isn't what prevents you from reaching light speed. Mass is the reason you're not already there. Everything in the universe, left to its own devices, wants to move through space-time at one speed, the speed of light. That's the natural state, the default. Light does it because light has no mass, zero, nothing to slow it down. But you have mass, and mass is resistance. Not resistance to motion through space, resistance to motion through space-time. Think of it this way. You're always moving. Right now, sitting still, you think you're stationary. You're not. You're moving through time. 1 second per second, that's motion through the time dimension. A photon moves through space at light speed, but doesn't move through time at all. 0 seconds per second. All of its motion is spatial. You move through time at normal speed, but you're nearly stationary in space. Most of your motion is temporal. The total speed, your speed through space-time, is the same for both of you. Light speed, mass determines how that speed is divided. How much of your light speed motion goes into space and how much goes into time. If you have mass, most of it goes into time. You experience duration. You age. You move forward through the temporal dimension while crawling through the spatial ones. If you have zero mass, all of it goes into space. No temporal motion, no experience of time, just pure spatial propagation at the maximum rate. This is why you can't reach light speed by accelerating. You're not trying to go faster. You're trying to redirect your motion to take the speed you already have, the speed you've always had, and rotate it from the time dimension into the space dimensions. But mass resists that rotation. The more mass you have, the harder it is to tip your motion away from time and into space. It's not that you need more energy to go faster. It's that you need infinite energy to fully convert temporal motion into spatial motion, because mass is the anchor, the thing holding you in time. And here's the part that should disturb you. Mass doesn't make you slower than light. Mass makes you experience time instead of space. You're not failing to catch up to light. You're being forced to take the long way through reality. Chapter 4, energy doesn't speed you up, it buys back time. You've been told that energy makes things go faster. That's not quite right. Energy doesn't make you faster, it makes you less slow. When you accelerate something, a particle, a rocket, anything with mass, you're adding energy, kinetic energy. And yes, from an outside observer's perspective, the object moves faster through space. But here's what's actually happening underneath. You're not increasing speed in any absolute sense. You're changing the object's relationship with time. The more energy you pump in, the more you slow down the object's clock relative to the rest of the universe. Time dilation increases. The object experiences less time per unit of external time. You're buying it out of the time dimension. Think about a particle accelerator. Physicists accelerate protons to 99.999999% the speed of light. They add enormous amounts of energy. The protons go faster and faster. But here's the thing. If you keep adding energy, the speed increase gets smaller and smaller. Double the energy, the proton barely speeds up. Double it again, even less speed gain. You're dumping in energy and getting almost nothing back in terms of velocity. The numbers stop making sense. You're pouring in exponentially more energy for logarithmically smaller returns. Where is all that energy going? It's going into mass, not the rest mass, the inherent mass the proton has when it's sitting still. That doesn't change. It's going into relativistic mass, the effective mass. The resistance to further acceleration. The faster you go, the more energy it takes to go even faster. Not because you're approaching some arbitrary wall, but because the energy itself is making you heavier. The object becomes harder and harder to accelerate. Its inertia grows. At 99% light speed, the object is so relativistically massive that even enormous energy inputs barely nudge it faster. At light speed exactly, the mass would be infinite. Infinite resistance. You can't push an infinite mass. You can't accelerate it. There is no amount of energy in the universe, even if you converted the entire cosmos into fuel, that would be enough. This is why light speed is unreachable for anything with mass. Not because there's a law against it, but because the closer you get, the more you become a prisoner of your own energy. The energy that was supposed to free you from slowness instead weighs you down. You're not climbing toward light speed. You're asymptotically approaching a horizon that recedes as fast as you advance. And all that energy you're adding, it's not making you faster in any absolute sense. It's letting you experience less and less time while the universe outside ages faster and faster. You're not speeding up. You're opting out of duration. Chapter 5, Causality Has One Speed. Here's the part that breaks everything. The speed of light has nothing to do with light. Light just happens to be the most obvious thing that moves at it, but the speed itself, it's not about photons. It's not about electromagnetic waves. It's not even about physics in the way you think of physics. It's about causality, cause and effect. The speed of light is the speed at which one event can influence another event. If you push a button here and a light turns on over there, there's a delay. Information has to travel from the button to the light. That information, the causal influence, can't move faster than light speed. Not because light is carrying it, but because causality itself propagates at that speed. Gravity does this too. If the sun suddenly vanished, Earth wouldn't immediately fly off into space. It would keep orbiting for about 8 minutes. The time it takes for the gravitational influence to cross the distance from the sun to Earth at light speed. Gravity doesn't travel through space as a thing. It's a curvature in space-time. But changes in that curvature, updates to the gravitational field, propagate at light speed, because that's the speed of information, the speed of influence, the speed at which the universe updates itself. You can think of space-time as a fabric if you want the metaphor, but it's not an instant fabric. It's not rigid. When you disturb it in one place, the disturbance spreads outward at a fixed rate, light speed. This is why nothing can go faster, not because the universe has a speed limit for objects, but because the universe itself can't process events faster than light speed. If you could send information faster than light, you'd break causality. You could send a message into your own past. You could receive an answer before you asked the question. Effects could precede causes. The universe doesn't allow this, not because of some cosmic rule, but because causality is built into the geometry of space-time itself. Events are separated by space-time intervals. Some intervals are time-like. One event can influence the other. Some are space-like. They're too far apart in space and too close in time for any causal connection. The boundary between them? Light speed. Light doesn't move at light speed because it's special. Light moves at light speed because it's massless, and massless things move at the speed of causality. The speed limit isn't there to keep things slow. It's there to keep the universe coherent, to ensure that causes always precede effects, that information flows in one temporal direction, that reality doesn't contradict itself. The speed of light is the refresh rate of existence. And you're living inside a universe that can't update any faster. Imagine you're chasing a beam of light. You accelerate. You get faster. You're now moving at half the speed of light. You check the light beam's speed relative to you, still moving away from you at light speed. You accelerate more. Now you're at 90% light speed. Surely the gap is closing. You check again. The light is still moving away from you at exactly light speed. Not 10% of light speed. Not a crawl. Full light speed. You push harder. 99% light speed now. You're barely slower than light itself. You measure the beam, light speed, exactly the same as before. This is not a mistake. This is not a measurement error. This is the universe telling you something profound. The speed of light doesn't depend on your motion. Every observer, no matter how fast they're moving, measures light at the same speed. Always. Exactly 458 meters per second. This is what Einstein meant by invariant Speeds are relative. If you're in a car going 50 kilometers per hour and another car passes you at 70, you see it moving at 20 kilometers per hour relative to you. That's how velocities add, normally, but light doesn't do this. If you're moving at 99% light speed and you shine a flashlight forward, the light doesn't leave you at 1% light speed, it leaves you at 100% light speed. From your perspective, light always moves at light speed. From a stationary observer's perspective, that same light also moves at light speed. Both of you are right. Both of you measure the same thing. This is why you can never catch light. Not because you can't go fast enough, but because fast enough doesn't exist. The closer you get to light speed, the more time dilates, the more space contracts. The universe warps itself to ensure that light always moves at light speed relative to you. You can chase it forever. You can accelerate endlessly. You can add infinite energy. And light will always pull away from you at exactly the same rate because you're not chasing a moving object. You're chasing the geometry of space-time itself. There is no frame of reference where light is stationary. There is no perspective from which light appears slow. No matter how fast you go, light is always moving at light speed relative to you. This isn't a wall you hit. It's a horizon that moves with you. You can approach it. You can get arbitrarily close. But every step you take toward it, the horizon takes a step away. Not because the universe is mocking you, but because light speed isn't a destination. It's the structure of the map itself. Feynman understood something most people miss. There is no absolute motion. You can't point to an object and say, this is moving at 100 kilometers per hour without answering the question, relative to what? Relative to the ground? Relative to the sun? Relative to the center of the galaxy? Motion is always relative, always measured against something else. Two observers moving at different speeds will disagree on how fast something is moving. They'll disagree on distances. They'll even disagree on whether two events happened at the same time. But here's what Feynman saw. They will never disagree on the speed of light. Every observer, regardless of their motion, measures light at exactly the same speed. This shouldn't be possible. If motion is relative, then speed should be relative too. If you're on a train moving at 100 kilometers per hour and you throw a ball forward at 20 kilometers per hour, someone on the ground sees the ball moving at 120. That's velocity addition. That's how motion works, except with light. Shine a flashlight on a train moving at half light speed, and the person on the ground doesn't see the light moving at 1.5 times light speed. They see it moving at light speed, exactly light speed, the same speed you see from the train. This breaks the intuition that velocities add. It tells you that light speed is not a velocity in the normal sense. It's something deeper. Feynman realized that the invariance of light speed is not a property of light. It's a property of space-time. Space and time are not separate. They're not independent dimensions that you move through separately. They're woven together. Space-time is a single structure, and the speed of light is the conversion factor between space and time. 1 second of time equals 299,792,458 meters of space. That's not arbitrary. That's the exchange rate built into reality. When you move through space, you're also moving through time. The faster you go through space, the slower you go through time. And the total speed, the speed through space-time itself, is always the same. Light speed, you can't measure your absolute speed because there's no cosmic reference frame, no universal stationary point. But you can measure the invariant speed, the one thing every observer agrees on, the speed of causality, the speed at which the universe connects events. Feynman didn't just accept that light speed is constant. He asked what kind of universe would require it to be constant. And the answer is this one: a universe where space and time are not separate, where motion through one affects motion through the other, where the geometry itself enforces the invariance. You don't live in a universe with a speed limit. You live in a universe where the separation between space and time is an illusion, and light speed is the crack where the illusion breaks.